For our last type of graph in this section, we want to look at a side-by-side bar graph. This is a bar graph where two or more groups are displayed in adjacent, i.e. side by side next to each other, bars on the same horizontal or vertical axis. You can do them vertically as well. So this will allow the data sets to be more easily compared because when you put them right next to each other, it makes comparing them easier. Now, note that the data sets are most often compared by using relative frequencies, i.e. percents or decimals. And that's because when you have different sample sizes or population sizes, it's not really fair to compare the raw frequencies. That can be a bit misleading. So one group might be larger in terms of raw numbers, but smaller in terms of percentages. So the percentages are a more fair way of comparing. So percents or decimals used for fairness, right? To keep it fair. For example, let's look at this particular group. This is a real data set. So this is a side-by-side bar graph, and it was the first gambling activity for NCAA student athletes. So they asked all the NCAA student athletes, where was the first activity you ever gambled in? And you can see we have men and women next to each other, so male athletes and female athletes. Now, respondents were limited to one choice, so they could only pick one as their first gambling activity. So that's why it's one choice, because it's the first one, hypothetically. And it was only among those who have gambled. All the NCAA athletes that have never gambled just were not in this particular data set. Okay, so here we can see lottery scratch tickets, playing cards for money, slots, betting on sports, betting on games of personal skill, and others. So these are the potential areas where they could have gambled. Over here, for comparison's sake, I wanted you to know the percentage of NCAA athletes overall that are men and women. And this is one of the reasons we don't use the raw numbers. There are way more male NCAA athletes than female. So if we did numbers here, raw numbers, frequencies, the male numbers would always be higher. But that's not really necessarily accurate. So we use percentages because that's how we're going to bring out something like this line being higher than this line. Okay, so let's look and see what percent of NCAA athletes overall are men. Right? It didn't say overall, but that's what it has to be. So that would be 62% because that's the dark bar. The dark bar is the men. So 62%. Now, I just said it. Why is this graph using percentages rather than raw numbers? That's because there are so many more male athletes than female athletes. It would not be fair to compare the raw numbers. If we compare raw numbers, the male bars will all be taller. But that's not actually accurate for what's really happening. So let me write that up. I'm going to have to give a little more space for that one in future. So there are so many more male athletes than female athletes in the NCAA that comparing the raw numbers would mean that men are higher on every single category because there's just more of them. But that's not really an accurate or fair way to represent the data, right? So for example, these ones for slots and lottery, if you did raw numbers, 6% of all the male athletes is a large number. 23% of all the female athletes is not actually that big because there's way less female athletes. So it would give you a distorted view of what's happening here and with the slots, right, for example. Right, so you want to compare the percentages because then you can get an accurate picture of where the disparities really are. Speaking of which gambling category had the largest disparity? All right, so largest disparity would mean difference. So the largest difference between the groups. And there are a few contenders, so we kind of want to look. So these two are 17 apart. These two are 25 apart. These two are 15 apart. All right, what I'm doing is 19 take away 4 is 15. Right, in my head. So 19 take away 4 is 15. So if I want to make disparity, if I want to take the difference right here, just to for our own benefit, these two are 17% apart. These two are 25% apart. These two are 15% apart. 19 take away 4 is 5%. This would be 9%. This would be 7%. Right? And this is not a gambling category. That's just there for our own purposes. So the largest disparity is this one. It's the playing cards for money, right? That is way more common for male athletes than it is for female athletes. And it's the largest difference. So let me write that up. There we go. Playing cards for money was the largest difference, the largest disparity for men and women. It was 25% higher for men, I guess I should say, than for women, which is a huge gap, right? In other words, it's way more likely for college males to have gambled on cards than college females, or college female athletes, I should say. Just another thing to note, even though I didn't ask for it, that is a huge difference for men and women there. But there's also pretty large differences for women versus men on scratch off tickets and slots. Women were more likely to have gambled in these two categories than men were. So that's kind of interesting. Something to note. This is more a game you play, right, with other people, whereas a slot machine, you're going to have to go someplace and get access to a slot machine and scratch off tickets likely similarly you have to buy those, right? But it's very not active, not with other people, whereas playing cards for money tends to be with other people. So that's an interesting psychological note, and somebody could study that difference for a psychology class.